Here we're going to look at how fast different types of vehicles travel. So we've identified that a hypersonic speed is one where the speed of the object is more than 5 times the speed of sound. That is, the object is travelling at a Mach number higher than Mach 5. 2 questions. How fast is that? And what sort of objects travel at those speeds? Why don't you grab a piece of paper and write down what you think are the answers to these questions. Then at the end of this unit, have a look back at what you've written. Pause the video now if you want to do that. Welcome back. It's the answers to these 2 questions that are the subject of this unit. We'll look at the sorts of speeds at which different vehicles travel, and look at those in terms of the Mach numbers at which they travel. We do this now so that you'll get some familiarity with the idea of Mach number, and so that you get some idea of the sorts of speeds at which different types of vehicles travel. In section 2 of the course, Vince Wheatley will take you into the details of how we calculate the speed of sound for different gases at different conditions. We'll see there that the speed of sound in a gas depends primarily on the type of gas and on its temperature. For now, let's restrict our considerations to air. At low altitudes, where the temperature of the air is, say, 15 degrees Celsius, the speed of sound is around 340 metres per second, or about 1,200 kilometres per hour. As we go up in altitude, the temperature of the air initially decreases. By the time we reach the altitude at which passenger jets travel, say 10 kilometres, the air temperature is typically around minus 50 degrees Celsius. Then the speed of sound is only around 300 metres per second, or about 1,080 kilometres per hour. When we go to even higher altitudes, the temperature rises and falls again, so the speed of sound rises and falls also. So here are 2 plots. The first plot shows how the temperature of the air varies with altitude through the Earth's atmosphere. Remember that typical jet aircraft will cruise at around 10 kilometres altitude. So here we have the temperature and we have the altitude. At low altitudes, the temperature decreases up to about 10 or 12 kilometres. Then there's a region of reasonably constant temperature. The temperature from about 20 kilometres to about 50 kilometres increases, and then at higher altitudes the temperature decreases again, so that by the time we get to the edge of the atmosphere, we're at temperatures lower than about minus 80 degrees Celsius. On the right-hand side is a plot of the speed of sound as a function of altitude. And what we see is that the speed of sound is decreasing when the temperature decreases, constant when the temperature is constant, and increases when the temperature increases. So the speed of sound for air through the atmosphere varies between about 1,000 and 1,200 kilometres per hour. So if we're talking about vehicles travelling at more than Mach 5, we're usually talking about vehicles flying at altitudes where the speed of sound is around that 1,100 kilometre per hour level. So we're looking at speeds in excess of around 5,500 kilometres per hour. Let's put that into perspective. We'll start with how fast different vehicles travel on the land. A car driving along a highway will typically travel at around 100 kilometres per hour. That's about 10% of the speed of sound for air at ground level. So a car will be travelling at a Mach number of less than 0.1. A Formula 1 car, as shown here, has a top speed approaching 400 kilometres per hour. So that's around 1/3 of the speed of sound, so Mach 0.3 or so. The fastest that any ground-based vehicle has travelled is up near the speed of sound. The world land speed record is just over 1,200 kilometres per hour, so we know that that's near Mach 1. This was achieved by a rocket-powered car. Now that's fast, but all of these are well below that 5,500 kilometres per hour ballpark figure for hypersonic flow. So no current land-based vehicles can be considered hypersonic. Let's move into the air. A small light aircraft, such as the Cessna 206 shown here, will have a top speed of around 300 kilometres per hour. That's around 1/4 of the speed of sound, Mach 0.25. A long-haul passenger aircraft, say a Boeing 747 or the Airbus A380 shown here, will cruise at a top speed of just under 1,000 kilometres per hour, about Mach 0.85, so still under the speed of sound but getting close. The first manned aircraft to break the speed of sound was this aircraft, the Bell X-1, a rocket-powered plane. In 1947, Chuck Yeager was the first man to travel faster than the speed of sound, around 1,130 kilometres per hour. That first supersonic flight achieved a maximum Mach number of 1.06. This was a monumental achievement in increasing the speed at which manned vehicles could fly. It showed that there's no sound barrier that prevents us from going to high speeds. Let's move forward into the supersonic era. The British-French alliance in the 1960s resulted in this aircraft, the Concorde, the world's fastest passenger aircraft. The Concorde could cruise for hours at just over 2,000 kilometres per hour. That's twice the speed of sound, Mach 2. There are some military fighter aircraft, such as this Grumman F-14, that have top speeds a little higher, some around 2,500 kilometres per hour. So now we're up to Mach 2.5, halfway to being hypersonic. The highest speed military interceptors, such as this MiG-25, have top speeds of around 3,000 kilometres per hour, Mach 3. The highest speed for a manned aircraft with air-breathing engines is the Lockheed SR-71, also known as the Blackbird. It could cruise at speeds in excess of 3,500 kilometres per hour, Mach 3.5. The Blackbird was powered by hybrid turbojet-ramjet engines. We'll look at turbojet and ramjet engines in more detail in the next unit. So, all past and existing manned aircraft that are powered by engines that use the oxygen in the air through which they're flying to burn their fuel have been well short of being hypersonic. There was one manned aircraft that did reach hypersonic speeds. The X-15 experimental aircraft was powered by rocket engines. It was carried under the wing of a B-52 aircraft and dropped at high altitude. This photograph shows a flight of an X-15 just after release. After release, its rocket engine was fired for a maximum of just over a couple of minutes. On one flight, the X-15 reached a maximum speed of 7,300 kilometres per hour. That was around Mach 6.7, so hypersonic at last. The X-15 was flown almost 200 times in the 1960s. In 2014, the X-15 still holds the official world record for the fastest speed ever reached by a manned aircraft. There have been some hypersonic vehicles powered by scramjet engines for short periods of time. In 2014, the official world speed record for an aircraft that's powered by an engine that breathes air is held by NASA's X-43 scramjet-powered vehicle shown here. It was unmanned and flew at about 10,500 kilometres per hour for several seconds in 2004. That's certainly hypersonic, at around Mach 10. So how far into the hypersonic regime have we flown? In our next video, we'll move out of the atmosphere and into space to find out.